Hey everyone! Today, we're diving deep into a fascinating technical showdown between a couple of heavy hitters in the world of cloud graph databases. And look, if you've ever had to deal with super connected data, you know that picking the right tool for the job is a huge deal.
For decades, we've gotten really good at storing data in tables, rows and columns, or as big JSON documents. But the question on this slide gets to the heart of the matter. How do you build a system where the connections between your data points are the most important thing? That exact problem is why graph databases were invented in the first place.
So why do these relationships matter so much? I mean, so much that they needed a whole new kind of database? Well, it's because some of the toughest, most complex problems we're trying to solve today are all about the links between things.
Just think about fraud detection. It's almost never about a single bad transaction, right? It's about spotting a whole pattern of shady connections. Or what about a recommendation engine that knows exactly what to suggest next because it understands what people just like you also bought? In all these cases, and so many more, the connections aren't just part of the data, they are the whole story. The real value isn't in the individual data points, but in the web that connects them all.
Okay, so how do we even begin to compare these different database services? Well, the key is a shared language called Gremlin. You can think of it as the SQL for graphs. It's part of the open-source Apache Tinkerpot project, and it's how you walk through, or traverse, that complicated web of connections to find what you're actually looking for.
Now, this quote on the slide is a perfect analogy. Think about it. Just because your phone and your laptop both have a USB-C port doesn't mean they're the same thing at all. They use the same connector, sure, but they are built for fundamentally different purposes. That is the perfect way to think about the databases we're about to compare. Just keep that idea in your back pocket.
And that leads us right to our two titans, Amazon Neptune and Azure Cosmos DB. Both of them support Gremlin. They both have that USB-C port, but as we're about to see, they represent two totally different philosophies on how to build a database. This isn't just about a feature list, it's a real clash of core design principles.
So in one corner, you've got Amazon Neptune. That's the specialist. It's a purpose-built, high-performance graph database engine. Its whole reason for being is to absolutely crush graph workloads, and that's it. Then in the other corner, you have Azure Cosmos DB, the generalist. This is your Swiss Army knife, a multi-model database where graph is just one of several tools it offers.
So how do these philosophies actually play out in the architecture? Well, the first couple of rows are pretty much table stakes these days. Both are fully managed services, and both auto-scale horizontally. But the real differences, the interesting bits, are in rows 3 and 4. Neptune gives you full ACID compliance, we'll touch on that in a sec, and it supports 2 different graph models. Cosmos DB, on the other hand, offers what's called tunable consistency and only supports the property graph model. So right away, you can see they're making very different trade-offs.
And this is the crucial difference. Neptune's full ACID compliance means its data guarantees are rock solid. It's all or nothing, kind of like a traditional bank transaction. This is absolutely critical for systems where every single update has to be perfect. Cosmos DB, built for massive global scale, gives you tunable consistency. This lets a developer literally dial back those strict guarantees in exchange for faster performance and lower latency, which might be exactly what you want for something like a social media feed.
And this quote just brilliantly illustrates how that architectural choice has real-world consequences. By default, when you ask Neptune for a node, it just gives you its ID and label, the absolute minimum you need. Cosmos DB, on the other hand, might return the ID, the label, and every single property attached to it. Just like the slide says, it's the same reason you're told not to use select star in SQL. At scale, fetching all that extra data you never asked for is just wasteful, and it can seriously drag down your application.
And the differences don't stop there. Because Cosmos DB is a generalist, because it has to support all these different data models, its implementation of Gremlin has some notable limitations. That match step, which is great for declarative SQL-style queries, it's not there. We already know true ACID transactions are out. And for the developers watching, the lack of features like Lambda expressions, which are basically just little on-the-fly functions, means some of your complex graph logic might have to be completely rewritten. It's the direct trade-off for being that Swiss Army knife.
Okay, so we've gone pretty deep on the whole specialist versus generalist fight between Neptune and Cosmos DB. But, they are not the only players in this game. So let's zoom out and take a look at the wider landscape of players, price, and performance. Let's take Neo4j, for example. They were one of the original pioneers in the graph space. They're very much in that specialist camp, just like Neptune. Their managed service, AuraDB, has this really clear pricing structure. You can start with a free tier just for learning, move up to a professional tier for production apps, and then go all the way to a business-critical tier with serious uptime guarantees for those apps that absolutely, positively cannot go down.
Now, Oracle takes a totally different path, kind of blurring the lines between specialist and generalist. For them, Graph isn't a separate product you have to go buy. Instead, it's an integrated feature inside their larger, converged database. What this means is, if you're already an Oracle customer, you get these powerful graph capabilities as part of the platform you already use, which can be a massive advantage.
And then you have the pure high performers, like Nebula Graph, which are built for just insane scale. I mean, look at these numbers. Their benchmarks claim they can handle graphs with trillions of connections, deliver responses in milliseconds, and process millions of queries every second. This is the specialist philosophy taken to its absolute extreme, designed for the most demanding AI and fraud detection workloads on the entire planet.
So all these different players and all these different philosophies, it kind of begs a bigger question. Why are there so many options? It's because the modern data landscape is way more complicated than just picking one database and calling it a day. The reason all these options exist really comes down to this key concept: polyglot persistence. It's a fancy term for a simple idea. No single database is good at solving all problems. So instead of trying to force one tool to do everything, a modern architecture uses different, specialized databases for different jobs: a relational database for transactions, a document store for content, and a graph database for relationships.
But you know, this creates a whole new challenge. This map here, it illustrates the mind-boggling complexity of what's called query translation. See, once you go down the polyglot persistence route, you have to figure out how to make all these different systems talk to each other. Every single arrow on this map represents the complex work needed to translate a query from one language, like SQL, into another, like Gremlin. It is not a trivial problem.
And all of this, the specialists, the generalists, the high performers, and the sheer complexity of making them all work together, it all boils down to one final, crucial question for you.
At the end of the day, when you look at your connected data, which of these philosophies makes more sense for your architecture? Do you need that dedicated, specialized tool that's been perfected for one specific job? Or do you need a unified, multi-talented platform that can handle it all? The answer to that question will shape a lot more than just your database choice. It could end up shaping your entire data strategy.